So today we'll start the topic-wise assignment related to alcohols and halogen alkanes. Was a topic we completed last week. So the table gives some data on the fuel. Biodiesel is there, LPG is there, petrol is there, and wood. Which fuel produces the smallest mass of a carbon dioxide on combustion to generate 100 megajoules of energy? So how we can work out which fuel will release the smallest amount of carbon dioxide when we to produce 100 megajoules of energy. So as you can see, if we have 30 like the 33 megajoules of energy is produced per liter, and when we produce 33 megajoules of energy from a 1 liter of the fuel, it releases 2.5 kilogram of carbon dioxide. So we'll check the ratio. If 33 megajoule produce 2.5, so 100 megajoules will produce X. Cross multiply. So it will be 30, 100 into 25, sorry, 100 into 2.5 divided by 33. So this will produce total, if we burn 100 mega, if we produce 100 megajoules, it will produce 7.57 kilogram of carbon dioxide. That's for 100 megajoules. Same thing, if 24 is to 1.5 is there, so 24 is to 1.5, so 100 will be X. So it will be 24 or 100 into 1.5 divided by 24. So this will give us 6.25. Then same thing, petrol, 32 megajoules of energy is produced every liter, and it gives out 2.3 kilogram of carbon dioxide per liter. So if we want to produce 100 megajoule, then it should be X. So cross multiply again, so 100 into 2.3 divided by 32. So this will produce 7.18 kilograms of carbon dioxide. And the last one, that is 10 is 0.9. So if 100 will be there, this will be X. Cross multiply. So 100 into 0.9 and divided by 10, so it will be 9. So this will produce 9 kilogram of carbon dioxide. The question is, which produce the smallest mass of carbon dioxide? So when we check the options, it matches with LPG, so B will be the right answer. That when you burn LPG, it produces the smallest amount of carbon dioxide to produce 100 megajoules of energy. Is it clear, this question? The first part one. Moving on to the next question. Which combustion of ethanol produce no change in volume of a gas present at room temperature? So it means the number of the moles of a gas before and after should be same. So if the number of the moles of a gas before and after are same, it means that does not produce any change in volume of a gas. So when we check the first option A, how many moles of gas on the reactant side? 3. How many moles of a gas in the product side? 2. So if the number of the moles of a gas changes, it means the volume will also change. When we check option B, 1 mole of a gas in the reactant side and there is no gas in the product, so 0 moles of a gas in the product. So it means because 1 becomes 0, it is also a change in the mole. So that's why it will be a change in volume, because the moles of a gas, if moles of a gas changes, the volume occupied by the gas will also change. When you check option C, oxygen is a gas, 2 moles of oxygen, and carbon monoxide is also a gas, and 2 moles of gas. So equal number of moles of a gas. So it means the volume will not change. That's why C will be the right answer. So if the moles before and after the reaction changes, it means the volume or the space occupied by the gas will also change. In question 3, grass is similar to many other plants in natural releasing mixture of volatile organic compound. The freshly cut grass has a characteristic aroma because of increased release of a compound which is known as the green leaf volatiles GLVs. The most important contributor to this aroma are alcohol and aldehyde containing 6 carbon atoms. So the compound mainly freshly cut grass, its smell is due to Z hex 3 enal. So there is double bond is there, that's why it is en, and aldehyde group is there, that's why al is also there. Human nose can detect Z hex 3 enal at a level about 1 nanogram per decimeter cube, or 1 into 10 power minus 9 gram per decimeter cube. This is what the human nose can detect, like that level. That's a concentration basically, because it is nanogram is the mass and dm cube is a volume, so it is mass per unit volume or it is a concentration. However, this compound is relatively unstable and rearranged to form E isomer. So some other GLVs are methanol, ethanol, Z hex 3 1 all, and E hex 2 enal, E hex 2 enal. It has been suggested that the release of GLVs is a part of a defense response from the plants. In one study, the plants attacked by caterpillar, the chemical composition of GLVs changes to attack the natural insect predators of these caterpillars. So, give a molecular formula of Z hex 3 enal. So, we have molecular formula means actual, which represent the formula which represent the actual number of atoms present, that is known as the molecular formula. So we have to check the total number of carbon, hydrogen and oxygen. This is a skeletal formula is given, so it means how many carbon. This is 1 2 3 4 5 6 carbon atoms are there, so C6. Then what about hydrogen? Because carbon maximum can form 4 bond. So if this is having 1 bond, so it means it will have 3 hydrogen here. This is having 2 bonds, so 2 hydrogen will be here. This is having 1 2 3 bond, so 1 hydrogen, 1 2 3 bond, so 1 hydrogen. This will have 2 hydrogen. And this one, because 1 2 and 3 bonds are there, so there will be 1 hydrogen. Because in a skeletal formula, we don't represent the hydrogen. So total number of hydrogen 3 plus 2, 5, 6, 7, 8, 9 and 10. So C6, H10 and 1 oxygen is there, so O. So C6H10O is the molecular formula of this compound. Draw the skeletal formula of E isomer. So we have to draw the skeletal formula. This is a Z isomer in which the two heavy groups are on the same side. We call that as, like, this is a carbon carbon double bond. So this is a heavy group and this one is a heavy group. So heavy group on the same side. So if you want to draw a skeletal formula, the isomer, but that is, this one is Z. We want to draw E, opposite side. So what we will do, we'll draw the same structure, but instead this was up, now we will make it down. So the heavy groups, one side it is down and the other side it is up. So that will become E hex 3 in al. And it is important that you read the question properly, because sometimes student used to draw a displayed formula, but as they mention as draw a skeletal formula, so you should use these lines. If this was a displayed formula, like draw the displayed formula, then you should represent all the bonds which are present in the molecule. Then an average nasal cavity has a volume of 30 cm cube, means this is a volume of the nasal cavity. Calculate the minimum number of molecules that Z hex 3 enal that could be detected. Avogadro's constant is given and the molar mass is given. So first In the beginning of the question, they gave you the concentration. That was 1 into 10 to the power minus 9 gram per dm cube. So if we have 1 decimeter cube, this is a mass present, but we don't have 1 dm cube, or we can also say 1 dm cube is 1000 cm cube. So the concentration is equals to, because this concentration was given in gram per dm cube, so it means this concentration is actually mass divided by volume. Concentration can be mass by volume, concentration can be moles by volume as well, or it can simply a ratio between mass and volume. So concentration is mass over volume, so concentration into volume will give us the mass. The concentration that was given 1 into 10 to the power minus 9 gram per dm cube, so this is 1 into 10 to the power minus 9 multiply by volume, that is in cm cube, so we have to convert into dm cube, so divide by 1000. So when we multiply, this will give us the mass of this molecule which is present, and after getting the mass we can find the moles here. So how to get the moles? We have the formula moles equal mass in gram over molar mass. So the moles, that was the main question, is equals to mass in gram. This whole answer 1 into 10 to the power minus 9 multiplied by 30 divided by 1000. This will give us the total mass. And divided by molar mass. So molar mass is equals to how much? It is 98. So we'll divide by 98. This will give us the moles. But in the question we need number of the molecules. So after getting the moles, this will give us the total number of the moles of this molecule which are present. It will come out about 3 into 10 to the power minus 31 moles will be there. But we need molecules to get the molecules, because 1 mole contains 6 exponent 23 molecules. So this 3 into 10 to the power minus 13 will have, so 3 into 10 to the power minus 13 times 6.02 into 10 to the power 23. This will give us the total number of the molecule, which is 1.8 into 10 to the power 11 molecules. Then complete the table with saturated straight chain alcohol having 6 carbon atom, that could be GLV, by giving one example in each case. Primary alcohol, primary structure, it means the carbon which is bonded with OH, it is surrounded by one alkyl group, that's called a primary. And if the carbon is surrounded by 2 alkyl groups, then it will be secondary. So alcohols can be GLV as well. So we just have to draw an alcohol with the 6 carbon atoms and to be a primary and structural formula. So in a structural formula, we don't represent, like we just represent how the carbon atoms are there, carbon and hydrogen. So it will be CH3, CH2, 1, 2, CH2, 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 OH. That is the primary. And what is the name of this compound? Because 6 carbon atoms are there, hex. They have a single bond N, and because of the functional group, it's all. So it is hexanol. We just have to rearrange and structural formula. So we can place OH anywhere, but keep in mind that only one hydrogen should be attached to a carbon which is bonded with OH. So if I draw CH3, CH2, CH, then there is OH, and then CH2, CH2, and CH3. So 1, 2, 3, 4, 5, 6. And what is the name of this compound? Because OH is with a third carbon from the left hand side, so it is hex, single bond N, and because third position we have OH group, so it is hexane 3-ol. Because they mentioned the structural formula, that's why I did not draw this displayed formula. This is very important. Like, you should be able to identify what structure they are asking. Sometimes they ask skeletal formula. If there was the same question and they say draw the skeletal formula, so 1, 2, 3, 4, 5, 6, and then OH will be there. And then 1, 2, 3, 4, 5, and there is OH 1, 2, 3, 4, 5, and then 6 is there. So this is not the structural formula, this is skeletal. So some student, like, just as you are doing this in exam, you should read the question properly, that which formula actually they are asking for. Then compound 2-chloro 2-methyl pentane contains 6 carbon, and this is a tertiary compound, tertiary halogen alkane, because the carbon surrounded by 3 alkyl groups, so it is a tertiary. It can be converted into tertiary alcohol when aqueous sodium, because when we add aqueous sodium hydroxide or potassium hydroxide, the halogen turn into alcohols. So complete the equation. So we have to complete what will be the product, because the Cl will be replaced by OH. So we can write NaOH here as a reagent, because this is the equation, or even OH ion is acceptable. But when I write NaOH, this OH will take position of Cl. So as a result, tertiary alcohol will be there. Plus NaCl. Then name class of a reagent, that hydroxide, because this will be partial positive, this is partial negative, so OH will attack on the positive center. So whenever it will attack on the positive center, what we call this, we call that as a nucleophile. So hydrogen is actually acting like a nucleophile, as it, the hydroxide is actually acting like a nucleophile because it is attracted towards the positive center. In different condition, 2-chloro 2-methyl pentane undergo elimination. Elimination reaction, it occurs when the same reagent is used in alcoholic medium. Complete the reaction, because whenever elimination reaction occur for halogen alkanes, that halogen alkane will convert into alkene. There will be a double bond. So this H and OH will combine with each other. H and OH will combine, and the Cl will leave. So the product which is formed here as an elimination reaction occur. So this H will be removed. So this carbon and the other carbon, which is with the halogen, can form a double bond with each other. So it will be H3C, then H3C, and there will be a double bond between the two carbon atoms. There is CH, then CH2. So this H I just draw in this manner, or I can even draw next to the carbon or bottom. So this is a product, plus H and OH will combine, so it will produce H2O, and then the chloride ion will be there. So how chloride ion is formed? As they mentioned, complete the reaction and with the appropriate curly arrow. So what happened? The chlorine is more electronegative than carbon, so chlorine will take both of the electrons which are involved in the bonding. That's why it will produce a chloride ion. So these two electrons which are involved in the bonding, chlorine will take both of them. So that's why there will be a chloride ion. And essential condition for elimination. So for substitution, essential condition, it should be in aqueous medium, but elimination, it should be in alcoholic medium. So when it is done in alcoholic medium, it will result in a formation of alkene. Is it clear, this question? That how elimination and substitution are different from each other depending on the medium in which we carry out the reaction. If sodium hydroxide or potassium hydroxide in aqueous medium, the halogen alkane will turn into alcohol. But if it is done in alcoholic medium, then it will undergo an elimination reaction. This is related to mass spectrum, so we'll do at the last because that is still left. Then Z hex 3 in 1R is sparingly soluble in water, but it is completely miscible in ethanol. Whenever the concept is like dissolve like. What does it mean, like dissolve like? It means that if two molecules have the identical type of forces, they will mix with each other, they will be miscible. If they have different types of forces between them, they will be immiscible. So when we compare, and it's a 4 marks. So detailed explanation for the factor involved are not required, but just you have to outline an idea that why it is sparingly or slightly soluble in water, but it is completely soluble in alcohol. So what kind of forces are there in Z hex 3 in 1 all? It will have polar because of like different atoms are there. It will also have hydrogen and it will also have non-polar. But when we check about the water, water is having hydrogen bonding only. And when we check ethanol, so comparing the force, like example, first identifying the forces within the molecule. So when we identify the forces within the molecule, because of OH group, whenever hydrogen, oxygen are attached, hydrogen attached to most electronegative element such as oxygen, nitrogen or fluorine, it will have hydrogen bond due to presence of OH. Then because two different atoms, carbon and oxygen will be there, so it will be polar bonds are there, and when bonds are polar, it will have dipole-dipole forces. And due to the carbon chain, it will have London forces. When we compare water, the major force, because hydrogen bonded with oxygen, so it will have only hydrogen bond. Dipole induced dipole force is there at all because the electrons are there, but major force is hydrogen bonding. Whereas when we check alcohol, ethanol, because of OH group, it will have hydrogen bond. Because of carbon and oxygen bond is there, so it will have dipole forces. Because when two different types of atoms or two atoms which are having a difference in electronegativity, they combine with each other, the bond get polar and they will have dipole force. And due to the carbon chain, it will have dipole induced dipole force, or you can say London dispersion forces. So when you check the type of the forces in ethanol, we have hydrogen bond. Here we have hydrogen bond, here also hydrogen. But when dipole force is there in ethanol, it is there in hexene. even in case of water, but because hydrogen bond is much stronger, that's why it is not able to interact by dipole-dipole. And dipole-induced dipole force, due to the carbon chain, London force or dipole-induced dipole forces are also there. So you should mention the presence of two types of intermolecular forces such as van der Waals force and the dipole-dipole force. And so hex 3 in 1 all can form a strong London forces with ethanol, so it can dissolve, but water does not contain, or water does not have London dispersion forces. That's why slightly soluble. It can form hydrogen bond, but not the London dispersion forces are not there in water. That's why, or very weak. That's why it does not dissolve completely. Sparingly only it is soluble. So whenever you want to write the answer related to solubility of a substance in a different liquid, first your approach should be, you should first write, identify the type of forces in different molecule, and then compare if they have like greater number of forces, identical forces are there, it means it is more soluble. And if few forces are identical, it means sparingly soluble. And if no force is there, no identical force, it means it will be insoluble. Which is a tertiary halogen alkane. So when we draw the structure, better you draw the structure. Tertiary means the carbon which is attached with a halogen surrounded by three carbon chain or three alkyl group, that is tertiary. So when I draw the structure for the first one, CH3Br, sorry, CHBr3. So one hydrogen is there and three bromine. So it is not tertiary because to be a tertiary, the carbon which is attached with a halogen alkane, that carbon should be surrounded by three alkyl groups. What about B? When we check for B, it is written CH2, Br3 and CH. So basically it's like C is there, H is there, and three of them are CH2Br. So CH2Br, CH2, CH2Br. So again, the halogen is not directly attached to here when we check carbon attached to halogen, it's having two hydrogen, not one hydrogen, or not, because tertiary means no hydrogen should be there. So it cannot be. When we check the third one, CH3 in a bracket 3 and then CBr. So CH3 in a bracket 3 means three alkyl groups are there surrounded by, the carbon is surrounded by three methyl groups, CH3 groups, and then next to that attaches Br. So this is the one, the carbon attached to halogen surrounded by three carbon chains. So what we call this, we call that as a tertiary halogen alkane. Then propene, which is an alkene, is formed by heating 1-bromopropane in alcoholic medium. So when alcoholic medium, what we call this reaction? We call that as elimination. If it was in aqueous medium, what we called nucleophilic substitution reaction. A compound with an empirical formula of C3H6 and O could be. So first thing, it's better you write the molecular formula of each compound, because from molecular formula you can identify the empirical formula. And to write the molecular formula, you should know the structure of each. So hex 3 hexane 1,2 diol. So hex means 6 carbon. So 1, 2, 3, 4, 5 and 6 carbon, and OH with the first one and OH with the second. Then this will have three hydrogen, this will have one hydrogen, two hydrogen, two hydrogen and three hydrogen. So 1, 2, 3, 4, 5, 6 carbon atoms are there. Then 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and 13, 14 are there, and two oxygen. So when we simplify this will be 3, this will be 7 and this will be 1. So 3, 7, 1. So it means it cannot be A. So it is C3H7 and O. It cannot be option A. When we check with hexanoic acid, hex means 6 carbon atoms. So this will have, the first one have 3 hydrogen, second 2 hydrogen, 2 hydrogen, and so on. So total number of the carbon atoms are 6 because of hex. Total hydrogen 3, 5, 7, 9, 11 and 12, and oxygen are 2. So when we simplify 6, 12 and 2, so simplest ratio between 6, 12 and 2 is 3, 6 and 1. So 3, 6, 1. So empirical formula of hexanoic acid is C3H6 and O. That's why option D is the right answer. Is it clear? In question 7, equal amount of 1 chlorobutane and 1 iodobutane is formed. When we add silver nitrate in the presence of ethanol, why does 1 chlorobutane react more slowly? What is the reason? Like, as we know, the reactivity when the bond is there between carbon and iodine, that react much faster as compared to bond between carbon and bromine, and that will react much faster as compared to bond between carbon and chlorine. So why does 1 chlorobutane react more slowly? Like, why this is having a slow reaction and while iodo is having a fast reaction? So when we check the options, CCl bond is more polar than Ci. So if it that is true, like example, chlorine is more electronegative, so this is more polar and this is less polar. But that does not give an idea of reaction, because if it was more polar, then it should react faster. But here, the polarity is not responsible for the reaction faster or slower. So that's why A cannot be an answer. The bond between carbon and chlorine is stronger as compared to carbon and iodine. That's true, because the bond strength, as uh, the size of atom increases, the bond length increase, so the bond strength decrease. So this is a weak bond and this one is a strong bond. So option B is the right answer, that bond between carbon and chlorine is stronger than compared to bond between carbon and iodine. So strong bonds, when bonds are stronger, the reaction of that compound will be slower. Then cyclopentene is a cyclic compound. It's a cyclic alkene, and cyclopentanol is a cyclic alcohol. Some reactions involving the cyclopentene into cyclopropanol are shown. Complete the displayed formula. So we have to complete a displayed formula in box A, box B and box C. Which organic products are the reactant? So box A we have to complete, box B and box C. So alkene is there, we reflux. So this is oxidation. And oxidation of alcohol, it will result in a formation of ketone. If it's a primary alcohol, it will oxidize to aldehyde, and then aldehyde oxidize to carboxylic acid. But if it is a secondary alcohol, then it will oxidize to ketone, and tertiary alcohol cannot be oxidized. So means this compound carbon bonded with OH, so it's surrounded by two carbons, so it means it is secondary. So secondary should be oxidized to ketone, so C double bonded with O will be there, and the remaining hydrogen according to that. This will not change, this will remain there. Then this is a hydrogenation or hydrogen added in the presence of nickel. So this is called hydrogenation, addition of hydrogen. So as a result, the double bond will break and all the carbon atoms will have, because this is a double bond, so this will break and each carbon will have two hydrogen. Then if we add a bromine, so it will decolorize, and again the addition reaction will occur between the two reactants, and it will turn into the dibromo cyclic alkane. So these are the products. So first one, it is oxidized to LP ketone. The second one, hydrogenation, means addition of hydrogen, and the third one is basically a test to check the presence of a double bond, or we can also say bromine water test. So give a test, because if we have a bromine, liquid bromine, so it is orange. Uh, If it is aqueous bromine, it is orange. But if it is a liquid bromine, it will be red brown. So starting color should be a red brown, and the final color should be, or finally it should be colorless. So from orange or from brown it is acceptable, then the final answer will be colorless. Then sodium hydroxide is added. So this is a nucleophilic substitution reaction. In aqueous medium, the halogen alkane convert into alcohol. So we have to draw an arrow to show, complete the mechanism. So the type of the reaction, that is substitution, and mechanism is nucleophilic. And the mechanism is nucleophilic. Then we have to draw an arrow. A bond breaking and bond forming will take place. Bromine will break a bond. This will attack partial positive negative, and as a result, the bromide ion will be removed. So this was about some question related to alcohols and halogen alkanes.